Problem 3 from system of particles and rotational motion. Question is, a coin is kept a distance of 10 centimeters from the center of a circular turntable. If the coefficient of static friction between the table and the coin is 0.8, find the frequency of rotation of the disk at which the coin will just begin to slip. So we have a one coin and it is kept on a circular turntable. Okay, so for suppose if it is circular turntable is like this, and this is our center of the circular turntable. Circular turntable means it can be rotating about one axis. Okay, so on that turntable we are keeping one coin, and this is our coin. It is about a distance that is r is equal to 10 centimeters from the center of the turntable. While this turntable is rotating, this coil may be trying to move out from the center of the turntable because of the centrifugal force which is acting outward from the center. But the frictional force between the turntable and coin, it is stops or it is keep on rest because of that frictional force. So this frictional force is cancelling the um, outward centrifugal force. But sometimes when it is rotating for first one, it is not slipping, second one not slipping, but at a particular number of rotation this coin may be slipped out. So before that slipping out slipped from the turntable, then we have to find out uh, frequency. At what frequency this coin will begin to slip. Okay, so for that they are given that the radius of the turntable, that is radius of the turntable is 10 centimeters and it is equal to 0.1 meters. Okay, so then again the coefficient of static friction, that is mu s, is also given, that is 0.8. Okay, so this coin is at rest on the turntable because of this centrifugal force is cancelled by the uh, static friction force. So from that when it is in equilibrium, then the centrifugal force is equal to static friction. So this centrifugal force we already know that mv square by r, and it is equal to frictional force mu s into n. In place of n we can write here m into g. 1m cancel, and it is v square by r is equal to mu s into g. So there is a one relation between the linear velocity and angular velocity, that is v is equal to r omega. That relation we are using here. So then this is becomes now v is equal to r omega square by r is equal to mu s into g, and this is equal to r square omega square by r is equal to mu s into g. 1r cancel, and it is equal to omega square r is equal to mu s into g. From that omega is equal to mu s g by r under the root. So this is our angular frequency. Then substitute the values. Angular frequency omega is equal to under the root of 0.8 into 9.8. Okay, mu s is 0.8 and g value is 9.8 and r is equal to 0.1. This point cancel, and omega is equal to under the root of 8 into 9.8. After solving this, we got this 8.85 radians per second. Okay, this is angular velocity or angular frequency, but this is also equal to, that is omega is equal to 2 pi by capital T, and that is equal to 2 pi into n. N is equal to 1 by T, that is frequency. Now we want to find out that frequency. So from this equation, that is omega is equal to 2 pi n, and n is equal to omega by 2 pi, and that is equal to omega is equal to, this is 8.85 by 2 into pi means 3.14, and it is equal to, so after solving that, we got 1.409 revolutions per second. Okay, it is, n means frequency. Frequency means number of rotations per second, but always in rotational motion we have to express it is in rpm. Rpm means uh, revolutions per minute, so it is revolutions per second. Okay, that's why if you want to convert this is rpm, then we have to multiply and divide this by what 60 seconds. Okay, that is 1.409 into 60 by 60 seconds. Okay, and that is equal to, this is 1.409 60 by 60 seconds. 60 seconds is nothing but here 1 minute. So if we cancelling this, there is no change. So into 60 rp, this 60 seconds we can write here per m. Okay, sorry, that is rp, rotations per minute. Minute means 60 seconds. Okay, it is equal to, after solving this, we got that 84.54 rpm. Okay, now this is for this rotations 84.54 rpm. Our coins is slips begin to slip.